Hello friends, in last lecture we discussed the broadening mechanism. In broadening mechanism we discussing about the first of all line broadening mechanism, and second is natural broadening mechanism. So third one is today we start the third one mechanism, collision broadening. In this collision broadening mechanism, in a gas random collision occur between the atoms. If atoms is emitting a wave train undergoes a collision, then phase wave suddenly altered. In this collision broadening mechanism, atoms can randomly occur, and that random collisions takes place between the atoms. So, if emit the wave forms, then the collision mechanism takes place in the phase form. This is the phase wave form. That mechanism will be start of phases. That the phase difference between two mechanism, this can be indicated by the line mechanism. The phase difference between two waves can be created. Each collisions may be viewed as a shortening of the wave. These waves in the form of short mechanism, where is a waveforms occurs in this way. So, we get the final resultant wave, that in this wave the collision takes place. The collision takes place between these waves, and these waves will be collisions takes place, the breakdown, and it will be converted in the full the formation of wave like structure. The frequency of that mechanism can be measured in the form of gigahertz. So, in this way the equivalent of broadening of the spectral line, this is known as the collision broadening. This spectra occur that spectral lines is known as the collision broadening. Figure see in this diagram, we get the lines mechanism in the form of spectrum form. The lines will be in the can be converted in the form of mechanism of by due to takes place the waveforms in the collision, and then that mechanism will be converted in the wave like structure. So, in this way we can be we get the collision broadening mechanism. So, next is Doppler broadening mechanism. So, in this Doppler broadening mechanism, Doppler effects occurs when a source and observer are in relative motion. These Doppler types of broadening occurs. Source and that effects of Doppler where we generated in the form of created the relative motion of the wave. So, in a gas of atoms move randomly and observer measure a range of frequency. When gas molecules is move in that atoms randomly, and that observer can be measures that range of frequencies of that atom. So, spectral line in the broadening mechanism, the broadening of line shape caused by Doppler effects, and that spectral line of broadening shape effects Doppler effects is called Doppler broadening mechanism. So, next is the homogeneous broadening mechanism will be the result in a Lorentz line shape. The line functions will be seen in the diagram. These lines will be Doppler effect according to Lorentz mechanism. So, in this way Lorentz line shape we get by using that Doppler broadening mechanism. These waves can be defined as a Lorentz line shape. This will be denoted by V minus V 0 upon in bracket bracket close upon alpha. This mechanism is takes place Lorentz line shape. So, Second is Gaussian line shape. In this Gaussian line shape, the lines mechanism can be breaks down in the form of the line broadening mechanism. The frequency can be defined as according to that the waves can be spectral lines that will be converted in the form of two session is x1 x2 x1 and y2 y1 is the upon 2. So, in this mechanism when a is greater than the in that y2 is equal to also 0, then center of axis x2 will be is defined as 0. So, frequency can be width of line width will be omega equals to w equals to 4. So, area can be defined as a of 10, a is equal to 10. So, this will be the mechanism takes place in Gaussian line shape. So, in this way the line functions can be denoted by created. So, GL of V is equal to del V upon 2 pi in bracket V minus V0 upon 2 plus del V upon 2 and bracket close 2. So, in this way the where V is denoted by frequency of lines and GL of V is denoted by the frequency of that line in the form of spectral line shape. So, this will be this mechanism can be used to break down the two frequencies of line between the wave function in the breaks down the two parts. So, homogeneous broadening mechanisms will the result in the Gaussian line shape. So, in case of gases, the line space function is can be denoted by G of V is equal to 2 by del V and in bracket ln of 2 by pi, where ln denoted by the line width and upon bracket close 1 by 2 exponential form of minus ln of 2 in bracket V minus V0 upon del V upon 2, V minus V0 upon del V upon 2 in bracket close 2. So, this equation can be denoted by as 2. Second, we get from equation first we get the GL in bracket of V0. GL of V is denoted by the frequency of line width. So, is equal to 2 by pi del V. This will be denoted by equation third. So, from equation second we get G small g capital G is in bracket V0 approximately 2 by del V. So, in bracket ln of 2 upon pi in bracket close 1 half 1 by 2. So, this will be denoted by equation 4. So, in this way we get the final equation of this mechanism G of V0 approximately 1 by del V. So, in this way we can prove that this Doppler broadening mechanism. This broadening mechanism included the Lorentz line shape and Gaussian function included. In this two function we can prove the Doppler broadening mechanism. So, thank you.